Hey, in this tutorial we're going to have a look at cubic polynomial functions. Hey, so we've got a few different forms here, like our quadratics. Hey, we've got our general form, which is y equals ax cubed plus bx squared plus cx plus d. Hey, we have stationary point form, which is y equals a outside of x take h cubed plus k. Notice I didn't call it turning point form. I probably won't refer to turning point form. We usually just say that for our quadratics. But stationary point, hey, which we'll learn a lot more about later on. Okay, is this point in the middle here, okay, which is going to be at the point HK. Okay, so our stationary point is at HK now, instead of our turning point. Okay, for our intercept form, we've got a couple of different ways that we can do it. Okay, we've got y equals a outside of x take n, okay, times x take m times x take p. So we're going to end up with our three different ones there. Okay, or we could have it as a outside of x take n times x take m squared. And what that's going to do is it's actually going to come up and touch the x-axis, so there'll be a turning point there, okay, and then we'll have one other one. Okay, so the way I think about it, okay, is this looks like it's a little quadratic in here, okay, and it's the term that's squared. Okay, and we know for our quadratics that's what it looks like. Of course, you could think that we've got the third one, which is y equals a outside of x take n cubed. Okay, that's really what happens here with our stationary point when h and k are 0, and this stationary point just moves down to the origin, and it'll just look like that. Okay, so what does our a do now for our cubics? Okay, so if a is greater than 0, okay, then we say as x approaches infinity, y approaches infinity, okay, and as x approaches negative infinity, y approaches negative infinity. Okay, and that's what's happening here. Okay, or with this one. Okay, so as x gets smaller, y gets smaller. As x gets bigger, y gets bigger. Okay. However, if a is less than 0, then as x approaches infinity, y approaches a negative infinity, and as x approaches negative infinity, y approaches positive infinity. So that is, as x gets bigger in our negatives, y gets bigger in our positives. As x gets bigger in our positive, y gets bigger in our negatives. Okay, so that's our basic idea around our cubic polynomial functions. I'm going to have a look at a couple of examples now. Okay, so our first example here, okay, is going to be finding the equation of our following graph. Okay, so we've got a cubic here. Okay, we can see that as x gets smaller, y gets smaller as well. So we know we're in that positive form. Okay. And we can see here that we've got a couple of intercepts. Okay, one's got this turning point here, so we know that's going to be a repeated intercept. So what we can do is say that we've got y equals a, we don't know what that is, okay, x plus 3 squared times x take 2 squared. Now notice what I've done here. Okay, this is positive 2, and this is, so that should be negative 3. Negative 3 there, but I've changed the signs. Remember, that's because we've got y equals a outside of x take n and x take m, etc. Okay, but we've got to switch our signs for that. Okay, we've always got to switch our signs. So it comes back to that idea of the null factor law that we've done previously, okay, where we say, because really we're solving this for equal to 0. That's what we're doing here. So when we say 0 equals x take n or x take m, we'll ignore the squared part at the moment, okay, that one of these two has to equal 0, so we'd say x take n equals 0, so x equals n. Okay, so where our signs have swapped for what n is. Okay, so just need to be careful there. So we've got to make sure that our signs are around the other way. Okay, so we've got that, but we don't have our a value yet. Okay, we need another bit of information, and we're given it here in our y-intercept. So when x equals 0, we know y equals negative 36. So we can put that in, okay, and solve for a. So x is going to be 0, which means we're going to be 3 squared. X is going to be 0, so we're going to be minus 2. Sorry, that should be squared. Okay, minus 2. Okay, so we've got minus 36 equals a times 3 squared is 9 times negative 2, so it's going to be negative 36 equals negative 18a, so a is going to equal 2. Okay, now we haven't actually answered the question yet. Okay, because we need to put it all together and say y equals 2 outside of x plus 3 squared times x minus 2. Okay, and by convention we'll put the one with our squared first as well. So we are starting with our highest power. Okay, so that's how we find our equation from that graph. Okay, then we've got another one that we're going to look at here. Okay, which is sketch the graph of y equals x cubed plus 4x squared plus x takes 6. And we're going to sketch that. That might seem like a pretty straightforward question, okay, but in our general form it is actually quite difficult. Okay, because we don't have any information to go off really. We don't have it in our turning point form or our stationary point form. Unfortunately, we don't have a complete and square method, okay, really up our sleeve so easily to utilise for this. Okay, so we've got a default, okay, to division of polynomials. Okay, if you're a little bit rusty on that, check out one of my previous videos on how to do division of polynomials, but we're going to go through it now. Okay, so what we need to do, okay, is find a factor of this. Okay, they'll give us 0. Okay, so we need to be able to sub something in here and have it equal to 0. Okay, and quite nicely, okay, if we put in 1 into here, okay, we'll find that that does work for us because we have 1 plus 4 plus 1 is 6. Okay, take 6 is 0. So we know 1 is a factor. Okay, so that means that we've got to set up our division of polynomials. So we go x minus 1, remember we've always got to change our sign, into x cubed plus 4x squared plus x take 6. Okay, I'm just going to start switching around some colours here. Okay, so remember our process. We need to go x cubed divided by x is going to leave us with x squared. Multiply back through, we're going to get x cubed minus x squared, bracket, bracket, take away line underneath. Okay, do the subtraction. Okay, we're going to get x cubed, take x cubed is 0. 4x squared, take negative x squared, will leave us with 5x squared. Bring down everything else. Plus x, take 6. Okay, now we're up to basically the same process again. Okay, so we go up 5x to the power of 2 divided by x is going to leave us with 5x. Multiply back through, we're going to get 5x squared. Okay, take away 5x, bracket, bracket, take away line underneath. 5x squared take 5x squared is 0. X take 5x will leave us with 6x minus 6. Okay, if I bring that 6 down. Okay, we're almost there, so now we go 6x divided by x will leave us with 6. Okay, then multiply back through. We'll go 6x minus 6, bracket, bracket, take away line underneath. 6x take 6, take 6x take 6. Here's of course 0, which is what we needed. Okay, so we're partway there. Okay, if you like, we now have our Y-intercept of x take 1. Then we'll go x squared plus 5x plus 6. Okay, now we don't have to do that process again because we can use any of our other skills to factorise our quadratic that we have left, and you can see this one is nice and straightforward for us. Okay, of x plus 2 and x plus 3 to factorise that quite nicely. Okay, so what we're going to do now is we can go ahead and sketch our graph. Okay, so the first thing we should always be thinking is we need to draw some axes. Okay, so I know I need to be going through, remember I've got to change my signs, -2 and -3, so I might spread these out a little bit. Okay, -2, -3, and +1. Y and x. Oh, now there's something that we haven't done yet either, which is what is our y-intercept? So what do we get when x equals 0? Well, we could do it from here, but it's much easier back here because obviously it's -6. Okay, now I don't have to stick with my same scale, so I'll make this our -6 down here. This is our 1, our -2, and -3. Okay, then we need to think about what is our a value, where our a value was 1, okay, which is bigger than 0, so we're going to have this shape to it. Okay, so we'll see how we go here. Okay, which should be something along these lines. Okay, so at the moment we're not too worried, okay, about what the coordinates of this point are. Okay, or well, and actually, in fact, I've probably done that wrong. Okay, because I assumed that was our minimum down there, which it probably wasn't in reality. Might draw it more like that for emphasis. Okay, at the moment, okay, we're not too worried about what the coordinates of those maximum and minimums are. Okay, we need a few more skills to be able to do that around differentiation. Okay, so at the moment, if we can do it based on that, I'll be pretty happy. Okay, so hopefully that'll get you through a bit of work that you need to do on cubic functions.